We've demonstrated how to create a project and how to import your data. And the example that we showed you was one in which the data was complete. What do you do when you have missing data in your data set? It's not uncommon, for example, if you're collecting survey data, to have certain subjects that don't fill in all of the questions in the survey. That is, they leave some of the questions unanswered or blank. In those cases, you'll have surveys that are partially or nearly all completed, but there will be some blanks. You don't want to throw the entire survey away, as the information that was completed is useful. So then you're stuck with the dilemma, what do I do when I have incomplete data? You'll see in front of you a spreadsheet where there are a number of visible cells that are empty. These 4 visible cells are shaded in reds. This particular spreadsheet has 1,190 rows. So what do you do? With SmartPLS, it's a 2-step process. The first thing that you need to do is to replace all of the empty cells in your spreadsheet with a number that I call the sentinel. The sentinel is a number that has such an extreme value that it's impossible for you to confuse that value with other valid data entries in your spreadsheet. Let's say that you filled in all of the blank cells, the empty cells that are missing, with a negative integer such as -99. Anyone looking at the sheet would know that those values were not real data and that they must represent empty cells. If you select all of the spreadsheet, and you can do that by simply clicking in the top left corner of the spreadsheet, then you can choose the replace option from the menu, and where it says find what, you leave it blank, and where it says replace, you simply type in -99, and then you say replace all. You can see that Excel completed its search and made 78 replacements. That means that I had 78 empty cells, which would have given me problems and errors if I had imported this spreadsheet directly into SmartPLS and tried to process it. So we've filled in all of the empty cells with -99, which is the sentinel. The next thing that you would do would be to save the spreadsheet and then import it into SmartPLS. We'll name it TAM Missing 1190 and we'll save it. And now we'll go directly to SmartPLS and we will import this data sheet. So we do this in the typical way. First I would create a project. We will call this project TAM Missing 11/05/2011 for today's date, and by default we're going to import our indicator data. And now we would drill down to the location where we have the missing data sheet. Here it is. So we say open, next. And here's where you have to do something different than if you're importing a data sheet that does not have any missing values. You cannot simply import a data set into SmartPLS that has blank cells. We showed you what to do, filling in the cells with a sentinel value, but then you have to tell SmartPLS that you have cells with a sentinel value and what the sentinel value is for those missing data cells. So you would click this on and you would enter in here what the sentinel value is. In our case it's -99, and you would say finish. And then you would proceed to validate the model just like you always do. That is, you double click on it. You can take a look. Notice you can see one of the sentinel values right here, -99 with an asterisk. The asterisk means that SmartPLS is aware that this is not a real data value, that this is an empty cell that you have marked with a -99. You can also see that particular entry here in the text view of the file. So we could proceed to validate the file, and it knows that when it sees -99, it's a missing value, so there are no problems validating the file. And now let's estimate the model. We'll first estimate the model using the data set that has missing values. All we need to do is go into the Calculate menu and choose PLS algorithm. Remember, we must tell it that there are missing values. So we check off the box that says Apply Missing Value Algorithm. We'll choose for this first case, case-wise replacement. So if I say Finish, here are our values. You can see that the path coefficient on the path from perceived usefulness to behavioral intention is 0.392. And you can observe that the R-squared for behavioral intention is 0.239. Let's estimate this model again, but this time we will use the correct data set. That is, the data set that did not have any errors. All we need to do to change to the other data set is simply point at that data set, right-click, and say Use Data for Calculation. Then you'll see that all the numbers on the graph disappear and we're ready to go. So we go into the Calculate menu once again and we choose PLS algorithm. This time the Apply Missing Value Algorithm checkmark is grayed out because we're using a data set that is complete. If we say Finish, notice that there are some slight changes to the values in our results. The path coefficient from perceived usefulness to behavioral intention increased slightly from 0.39 to 0.40, as did the R-squared value for behavioral intention. Although this change is not a large change, keep in mind that it simply was a matter of excluding a few dozen records out of 1,200 to create this different effect. Imagine if you had a small data set and you excluded a few dozen records. It could seriously bias your results. What would happen if you applied the missing data set and you forgot to check off the Apply Missing Data algorithm? Let's try that. So I go back and I identify the missing data set as the one that I'm going to use for calculation, and I proceed to run the PLS algorithm. And this time, let's say I'm careless and it was turned off and I didn't notice, and so I didn't turn it back on. Look at how it affects the results. This path coefficient that was quite strong at 0.40 now is 0.052, not significant at all. And the R-squared values for BI that were almost 30% are now 0.036%. It had a very large effect. Why is that? Well, remember what we did was we replaced all the missing values with -99. So when SmartPLS ran the PLS algorithm this time, every time it encountered a value of -99, it thought that that was the real value, and it proceeded to estimate the model using those values, -99. The rest of the values were on a scale from 1 to 7. No wonder it skewed the results dramatically.